Good morning. I'm Adam Meyers. I think I might be the most overdressed person at this conference. It's a clear indication I've been working where I have been for too long. All right, so I'm going to be talking about what I like to call broken arrows today. I went on Wikipedia and I pulled down this definition of what a broken arrow was, thinking, maybe that would provide some relevance. But apparently it's strictly involving nuclear weapons that get lost, which is a completely different subject. So anybody that thought they would hear about lost nuclear weapons, that is not this talk. But also something that really makes me nervous that they have a code word for. A lot of people question using Wikipedia as a source, but as Michael Scott on The Office said, it's the best source for information anywhere. So that's where I can point my relevance on that. So what I mean by a broken arrow is a weaponized computer bug captured in an operational environment. When a broken arrow is found, it can potentially allow an operator to better defend a network. So finding these things and figuring out who's using them against you and what's being used against you will give you some idea of where to patch and what kind of things you need to be worried about. So a couple of points before we get started here. There's really probably anybody out there doing exploit development? Nobody? Okay. How many people are doing computer network defense operationally? Okay. Anybody studying to do that? Okay. I'm just trying to get a feeling. I've never been to this conference before, so I just watched a guy talk about attaching pins to a chip and melting the coating with acid, so I wanted to make sure I was somewhat relevant. So zero-day exploits are generally a special occasion. Zero-day, which can be leveraged reliably against a target, is even more special. This isn't something that happens every day. People that have 0 days tend not to use them unless they need to. The purpose of what I'm going to be discussing is not to find a 0 day. This is kind of detailing some of the technical analysis that can occur once you've identified that you have some sort of exploit code out there. And no systems were hurt during the production of this presentation. Everything was done virtualized. So I always like to start off with goals. This way you can't leave and say, I went to that presentation, didn't cover what he said it was going to cover. So a couple of the goals for this presentation are to learn some tools that are useful in reversing exploits. Things you can do, I want you to walk away from this presentation and be able to, if you haven't already done this, take exploits and have some idea of how to kind of mess with them and figure out how they work and what they do. Learn when you need to break an exploit in order to facilitate analysis. So sometimes you do need to actually hobble an exploit to make it a little bit more easy to analyze. And finally, or there might be one more, learn how to break an exploit to better analyze it once you've established that you need to, and lastly, to have some fun playing with exploits. So one of the questions I always get asked as a consultant is, who are you and what are you doing here? So here's the quick spiel about SRA. We do government consulting. Myself, I've spent the last 8 years working for SRA as a security consultant for federal clients, doing penetration testing in that realm, conducting forensics analysis, security architecture review, and I'm currently, I run a team of reverse code engineers over at the State Department's Bureau of Diplomatic Security, which is why I'm constantly overdressed. And we take malware and exploits, reverse engineer it, and figure out kind of what it does and who sent it. So I'm going to take a quick sidestep here. I promised my team that I would I put this slide into every presentation that I do. That was fall 2008. So please meet J.K. Giancarlo Benitez, shirtless Peruvian friend here, who is into rock and metal and writing poor malware, among other things. So he left his name in some malware that he wrote to steal banking credentials that ended up at a certain US government agency. It included his full name, so it was pretty easy to find his High5 account. Unfortunately, he was 18 and living in Peru, so we couldn't get anybody to go arrest him. So if anybody sees him, you know, let him know that his picture is on a bunch of presentations someplace that some guy in a suit's giving. So coming from the corporate world, I need to have a pretty heavy disclaimer. It's actually, I think the Pledge of Allegiance is in there and some stuff that I copied out of Microsoft EULA. Also, I'm a little animation heavy on my presentation, so I hope nobody gets nauseous. All right, so a little background. So 0-day, as I said, are rare. If somebody's smart enough to have an O-day, then they probably are smart enough to use it properly and not get caught. Some 0-day can actually be old bugs, which are previously unexploited or perhaps unpatched. Also, you sometimes will find that a bug that was previously thought to only be like a denial of service actually can lead to remote code execution. So sometimes it's worth it to go through some of the old vulnerability databases to look at that stuff. Occasionally, you may get lucky as far as finding when somebody's using an O-day against you. They might actually operationally not send it properly or use it properly, or they'll accidentally leave it as forensics evidence. And the note there was that obviously not anyone would be missing an Adobe or Microsoft Office patch. That's just unheard of. So targeting vectors. So where these exploits are coming into the environment, where you can actually identify them and perhaps snag them from an operational standpoint. We have remotely exploitable. So we see SQL injection, HTML, other. Application-specific stuff that's targeting Apache or IIS or something that's kind of hanging out as a publicly available service or on the internet. That, in the real world, is not something that I focus on. I focus more on client-side exploitation, so you'll kind of get that from this presentation. Some client-side stuff that is out there and pretty common. Browser targeting things like Internet Explorer, Firefox, Safari. Also cross-site scripting attacks. If anybody followed what just happened to Apache, they got popped pretty bad using cross-site scripting that targeted an administrator. And my favorite, which is file format vulnerabilities, Trojanized attachments, things like PDF, Office, etc., or a web link to something like that. So you might see somebody put a link to a PDF in order to exploit, Internet Explorer's PDF rendering and how it does that. So common exploitation paths. So I'm sure most people are familiar with the common bugs that are out there, buffer and integer stack overflow type stuff. Function pointer overwrites. There was one example I considered using for this that was in a Microsoft Excel function pointer overwrite that you can grab. It's publicly available. Kind of an interesting exploit and really fun to kind of go back. It was one of the earlier ones that we worked with as kind of our background for how we made this a repeatable process. Heap pointer corruption, use after free, integer array overflow type stuff. And one of the things that really makes this possible in the environment that we're working in is that there's a lot of advanced file formats with robust input capabilities, and they lend themselves to these bugs that are out there. So things like PDF and how it can render all different types of graphics libraries and things of that nature. Certainly, there's a lot of room for error there, which I'll show you in a second. And fuzzing file formats with multiple hooks and interconnects, such as PDF, can yield a lot of exploitable bugs. So if anybody is looking for exploits, that's certainly a good place to start, looking at PDF and how it incorporates other components. So again, as I said, there's going to be a Trojanized focus to some of this based on the type of stuff that I'm seeing. Targeted attacks are very profitable from an attacker standpoint. For example, the attack against Apache, maybe somebody heard about the attack against Google, some of those types of things.